to the Python online lectures. I want to show you how to plot graphics. Let's begin by importing the NumPy library and the matplotlib library. Now assume I have two lists that I want to plot. For example, my x values 0, 1, 2, 3, 4, 10 and 15. Y values 0, 2, 5, 1, minus 4, minus 1 and 3. Okay. To draw a two-dimensional graph x versus y, you say plt plot x versus y. Very simple graph. Save the file and then press F5 to see the result. Okay, I can see a connected graph of 7 points. I can see, if I want to see only the data points, I can supply an extra parameter. A string variable O will make the graph with data points only. So let's run it once again. There you have the 7 points. One other option might be lines with the dots indicated. Okay, this is also a helpful way to look at your graphs. And one other option I want to show you is the dashed line. There are many other options available in the help files. You can consult the help files there. But let's stick to the simple line graph. Okay, a couple of other functions that you will find helpful are the title function supplies a title to your graph. So let's run it. You can give a label to the x-axis and y-axis using the x label. For example, say this is time, and then y label amplitude. So let's run again. Okay, on the graph you can see the title here, y value, and then x value over there. Good. Let's continue. I can also manually supply my x and y limits. Let's supply larger limits with y limit. In this case, you will see that my limit is a little larger than smaller than -4 and larger than 4. So how about we make them -8 and 8 there. Okay. And likewise, I can also change the limits of x. I can make it smaller or I can make it larger. In this case, let's make it a little smaller, starting from 1 and then ending up at 20, for example. So let's run the graph again. Okay, I mixed the x and y's over there. So this is supposed to be the x. Okay, so x limit starting from 1 and then goes up to 20. But you don't see the 1 here as the ticks are automatically created in this case. I can also supply the ticks, and next I want to do that. So let's start from 0, and this is my whole graph over there. I can supply the ticks, plt x ticks. I want to use, for example, 0, 4, 8, 12, 16, and 20. If you run it, you will see exactly the same numbers that you supplied as the ticks. You can have less or more or less ticks as you like. So for the Y ticks, I just want the 0, for example, and the 10. 10 is not visible over there, so 0 and 5. So it's so you can see I have my X labels and Y labels assigned according to the parameters I supplied here. One neat way to use this might be to supply the X list and the Y list over there. So these are the points that I use. So I am supplying my X list and Y list there. Okay, before finishing this part of the discussion, I want to just show you if you do, for example, X, okay, this is what I want to do, sorry, so leave it like that. If you set the X limits in the inverse order from 20 to 0, you will see the graph inversed also. So this can be helpful in the future. So very short introduction to 2D graphics. Next we will do graphics of NumPy arrays. Okay, in this part I want to show you how to plot graphs of NumPy arrays. So let's create a NumPy array. I want to do a linspace values for X starting from -5 to 5. I want to have, say, 10 points. And as Y values, I want to do a polynomial x squared minus 12x plus 5. Okay. Now I want to save this as a different Python file first, and then run. Okay, so here is your X values and these are the Y values. I want to plot it using the same plot function that I used for the lists. This time I have X and Y. It looks like exactly the same with the lists, so let me plot it. So here is my polynomial from -5 to 5. If I want to see the data points, I can do something like this. This is not exactly what I want, so here is the data points and the polynomial. Okay. Next I want to show you how to do two different curves on the same graph. Let's have a second curve, say y2, and let's make this a cubic function, minus x cubed plus 2x squared minus 5. Okay, and let's call this now y1. So I plot the first one and the second one exactly the same, this time y2. Now let's take this away and then run it. So I have two functions plotted on the same graph. the x and y limits are selected appropriately. Now as you see, this polynomial looks rugged, so let's make the sampling a little larger to make it look more smooth. So I increase the sampling, and now I have a nice and smooth curve like that. At this point I also want to show you the legends. So if I want to call this my, say, quadratic function, and then this, call it the cubic function. So if I label them as this, I can use a legend on the graph. So if I run this with F5, so the labels I supplied here appear on the graph. The colors of the lines are also indicated in the legend over there. Okay, so multiple curves on the same graph. Next, I also want to show you something extra before I finish this part, to indicate the difference between these two functions. You can also use a plotting option, this fill between. So fill between y1 and y2. Filling between y1 and y2 will give you a result like this. This can also be very helpful in your future studies as well. Okay, now let's see how to draw bar graphs with a simple example. Let's have our y values as random integers between 0 and 20, and how many of them? Say 15 of them. Okay, save your file, give it any file name you want, so run it. Okay, run it by pressing F5. Let's have a look what the y values look like. So this is an array of numbers, 15 numbers between 0 and 20. So if I want to do a normal graph, of course they will look like that, for example. So this is my numbers, but instead of dots, I want to do bar graphs this time. So this is how I do that. For each y value I need a x value as well, so I want to create a range of numbers from 0 to 20. Yes, each 15 numbers, so I need 15 here. Okay, so let's run this, and I want to show you. So these are my list of random numbers, 15 of them, and this is my x values starting from 0 to 14. So a bar graph is drawn by saying plt.bar, supply it the x and the y. So let's run it. Okay, this is your array, and every time I run this program, of course a random array is created. So these are my values. If you remember from the previous discussion, if I want to use, my numbers are always integers, so it's better to have integer values here as well. So I would do it that way. Y so plt y label, I want to have integers starting from 0 to 20 as the ticks, of course, not the labels. Why ticks? Because this representation, this ticks here is a bit misrepresenting my values. My values are always integers, so I prefer to use integer ticks. So let's run this. There you have. Okay. If you think this is too much crowded or cluttered, I can do something like this, which will look much better. Okay. The thing is, 20 is not included there, so I would prefer 21, so I can see that as well on the. That looks very good. Okay, so that's a bar graph. Now I have a range of values. I can also sort them if I want to, and this is how one sorts numpy sort y, and then I can plot the sorted ones. So these are my random numbers as a bar graph, but this time sorted. Okay. I want to conclude this discussion not using the sorted values, but so this is my y values. Let's plot it once again. Okay. Now, if you know what a histogram is, you can also plot histograms. A histogram shows you the frequency of a value appearing in a list. And very simply, you can do the histograms of a list by supplying the list and the number of bins. For example, if I have my bins 20, let's plot this and then we discuss. So I want to comment that to just have the histogram. Let's look at this. Okay, this histogram gives you the frequency of your data values. To make it more understandable, let me do a few things here. First, I want my x ticks to be numbers. So I have 20 numbers, 20 different values over there. So if you compare, we had 15 on the x-axis here. This gives you the range, the y range over there. So my x ticks would be up to 20, starting from 0, 20, and 4. I think this will look better. Okay. So, and it will help if we plot the xy values there also. And the show line will make sure the two graphs are not plotted on top of one another. So run it. Okay, so these are your random numbers. I want to spend some time discussing this. So I have a list of 15 numbers. The first one is 17, the next one is 13, 6, 1, and I have a 0 over there also, and so on. Now the histogram shows the frequency of each number. For example, here a 0 appears once, and this is your 0 over there, and the 1 also appears once there. This value 4, 5, and 6, the 6 appears 2 times. So here is your one of the 6 over there, and the other 6 is there. So if a histogram shows you the frequency of your data points. But a histogram, it's a statistical function, therefore it's better used with a large number of data points. Next, I want to create a large number of random points and then look at their histogram. So let's take this away. My data points, I want to create random points here now. Random points, say 100 random points, and then let's plot them and let's see what they look like. I only want to plot the points, so these are in total 100 random points. Okay, and if I want to do a histogram of y separately, so random points and their histograms. So nearly I didn't supply a bins value here, so I should do the bins. I want to do 10 bins there. Okay, so some of the values, actually now these are random numbers between 0 and 1. So by creating 10 bins, I divide these numbers into 10 equal bins from 0 to 0.1, from 0 to 0.1, from 0.1 to 0.2. So this is the frequency. We actually have 3 numbers between 0 and 0.1, and this is what you see over there. See, so these 3 points are between 0 and 0.1. Now, because 100 is not really good for enough for the statistics, we have a not so uniform distribution of the random numbers. They should be uniform actually. So increasing the number of points to 1000, for example, now I can see more or less the uniform distribution of my points over there. Okay, now I want to do the same with the normal distribution, normal statistical distribution. So here I have 1000 points, random points, but this time distributed in what we call a normal distribution or a Gaussian distribution. Look at the limits. The limits are 0 to 1 in a uniform distribution. It will be different in the next one. So let's have a look at that. Now this is a Gaussian distribution or a normal distribution. Most of the numbers lie near 0, but you sometimes get numbers away from 0. And this is this you can see on the histogram here. Most of the numbers are between 0 and 0.1 or near 0, let's say, and then you don't have any numbers larger or smaller than -3 in this case. So I can let's increase the number of points once more to 10,000, and then let's run this. Okay, so now our data points are really between nearby 0 and then sometimes scattered up and down, but we don't have any values minus a lot smaller than -4 and larger than 4. So increase the number of bins to get a better resolution on the histogram. So you see we have a nice Gaussian curve here. So this is basically the bell curve. Sometimes we call the bell curve. Statistically, most of the numbers are between 0 and -2. Okay, so histogram helps us discover the statistical distribution of data points. Let's stop here. So we discussed the bar graphs and the histograms related to bar graphs in this part of the video.